The sun is the superpower of our solar system. A thermonuclear blast furnace erupting with massive explosions.
It can be the same amount of mass as Mount Everest coming out from the sun and flying out into space.
At 93 million miles away, it would seem that we're safe from the sun's wrath. But are we?
It matters, especially in modern times, what the sun is doing.
From the center of the sun, as it rotates around, is the kill zone.
With some experts predicting the most violent outbreak of solar activity in modern history, it's never been more important to understand the secrets of the sun. There are billions of stars in the universe, but one alone dominates our cosmic neighborhood: the sun. It's an infernal sphere of mostly hydrogen and helium, superheated into a plasma that burns at millions of degrees. Its surface rages with violent explosions as it spews out storms of deadly radiation millions of miles into space. Our sun is a type of star known as a yellow dwarf. Yellow because of the color of its surface, and dwarf because it's small for a star. But small is relative. Within its boundaries, you could fit 1 million Earths. Our star is an enormous source of heat and energy. It has a surface temperature of 10,000 degrees Fahrenheit and generates 380 billion megawatts of power. This dwarfs anything on the human scale. Hoover Dam in Nevada only generates 2,080 megawatts. In 1 second, the sun churns out more energy than has been used in all of human civilization. All that power in the blink of an eye. Incredibly, it's been burning this way for billions of years.
Early astronomers didn't quite understand how the sun could generate so much energy for that long a period of time. That was the first mystery, was really how the sun generates its energy.
In the sun, these objects are hydrogen atoms flung together by immense pressure to form helium atoms. In this fusion process, the resulting atom is slightly less massive than the ones that created it. The missing mass is given off as energy. Each second inside the sun, 600 million tons of hydrogen are fused into 595 million tons of helium. That 5 million tons of mass lost in the process is converted into energy equal to 1 billion 1 megaton hydrogen bombs. That's every second. How light gets from there to here turns out to be an incredible story. The energy created in the fusion process is carried out of the core by particles of light and heat called photons. They are what bring the warming rays of the sun to Earth. To reach our planet, these glowing travelers from our nearest star must first take a long, winding road through all the layers of the sun, like Dante journeying through the levels of hell. First, a photon enters the 185,000-mile thick radiative zone. The region is so densely packed that the photon constantly bumps into other particles, like hydrogen and helium atoms. It struggles outward in a chaotic zigzag pattern that scientists call the random walk.
A photon can't escape without interacting over and over and over and over again, getting absorbed by atoms and re-emitted, and it can be absorbed and re-emitted millions of times. As the density decreases, as you get further up in the sun, it becomes easier, and the collisions and the interactions are less.
When it finally reaches to within 130,000 miles of the surface, the photon enters the convective zone, and the pace suddenly quickens. It's carried upwards by a kind of boiling, riding along in huge columns of gas at hundreds of miles an hour, taking only 10 days to emerge on the solar surface. The incredible journey is almost over as the photon lifts off through the wispy gases of the solar atmosphere. From there, it takes only 8 minutes for it to zip across 93 million miles of space to our planet. For the sun, even 1 million years is a small blip in time. The simple, perfect disk of a sunset belies the long, violent history of our star. It is a ball of fire spawned billions of years ago in a massive explosion known as a supernova.
After this titanic explosion, where a star much larger than the sun exploded, there would have been a huge cloud of gas, many times larger than the solar system. And small knots of material would have gradually coalesced in this very large cloud.
About 5 billion years ago, some 10 billion years after the Big Bang that scientists believe kick-started our universe, this cloud started to collapse under the pull of gravity.
Our solar system probably arose from one such knot of self-gravitating gas that pulled itself together and gradually spun itself up as it pulled in, like a skater pulling her arms in during a spin, until the star and the various planets coalesced around it. Ultimately, when the star was dense enough, it would have turned on fusion, started glowing, giving off sunlight.
Earth and the other planets in the solar system formed out of the same knot of gas that produced the sun. In this process, the sun hoarded 99% of the mass. This means it's the biggest object in our celestial neighborhood with the strongest gravitational pull. That's why everything else revolves around it.
The universe is brought to you in part by Monster.com.
It seems impossible to believe, but it won't be around forever. Eventually, even the sun must die.
Unfortunately, the sun will not go out with a bang. It is too small to erupt in supernova. However, stars do a peculiar thing. They're one of the few things around that get hotter as they cool off.
As it exhausts its hydrogen fuel, our nearest star will cool and gradually collapse under the force of gravity. Energy from this collapse will start heating up the core again to hundreds of millions of degrees, hot enough to start burning helium. Under the extra heat of the helium burning, the star will expand into a monstrous orb called a red giant.
It gets so big, it will engulf the entire orbits of Mercury, Venus, and Earth. You don't want to be around for that. You want to be planet hopping your way to safety long before this happens.
The Earth is likely to change its orbit slightly as the star expands so that it won't be engulfed. Still, talk about global warming, you wouldn't want to be there.
The outer layers of our sun will eventually become so unstable that they will fly off into space, leaving behind a small core about the size of the Earth.
So remember, we've shrunk most of the sun, which is 1 million miles across, to the size of the Earth, which is more like 6,000 miles across.
Our once great star reduced to a slowly cooling cinder.
And life as we know it on Earth will cease to exist. And that is the death of the sun.
For now, humanity basks in the glow of a sun in the prime of its life. Science has uncovered many of the secrets of our nearest star, but we remain awed by its beauty and ever more wary of its wrath.
This face on Mars is not an alien monument. Explore Mars in the universe next week.